So today we're going to be working on 6.6b properties of logarithms. Again, it's going to be the same properties we learned in 6.6a, but we're going to be talking in details about those properties, how we can use them to solve equations and finding variables and so on. So let's review the first rule. The first rule says, and it's called the product property of logarithm. And what does it say? It says, in words, the logarithms of a product is the sum of the logarithms of its factors. What does that mean? It means log base b of mn would be log base b of m plus log base b of n. In example, in numbers, log base 3 of 4 times 7 would be equal to log base 3 of 4 plus log base 3 of 7. So 4 times 7 could be 28, but you can use 4 times 7, you can do 2 times 14, so anything that would multiply to give you this value. So let's start with the first example. They're asking us to rewrite the equation using the product property and to solve for the variable. Now remember, since this is just the notes, I'm telling you what property to use, but later on you have to be able to solve mixed problems. So let's start with number 1. Log base 6 of x plus log base 6 of 9 is equal to log base 6 of 54. So how can we do that? Let's try. Now I can combine those two to create 1. So log base 6, instead of x plus log base 6 of 9, I'm going to put 9x is equal to log base 6 of 54. So what I really did is I combined those two into 1. Now look at those two. Don't you have log 6 on both sides? So you can just cancel them out. What do you get? 9x is equal to 54 divided by 9 divided by 9. So x would be 6. And that's the answer. Now always remember to plug it in to check. So let's try that. 6. Log 6 base 6. It does work because 6 is positive, so it's fine. So it's acceptable. It looks acceptable to me. So remember, if you have to and they're being added, you can write it as 1. If you have log 6 on both sides, you can cancel it out. Now let's move on to example number 2. Example number 2. Now, again, I can rewrite those two as 1. Since they have addition, I can multiply d and 3. So it would be log, I keep the same type of log, so base 3. And I can multiply d and 3 to get 3d. Okay, so let's review what I did. Addition, so you multiply d and 3, d times 3, you can write it as d3 or you can write it as 3d, which is much better. Now, in the first example, let me lower this so you can be able to compare them. You had log 6 on both sides, so we were able to cancel it out. Here, we do not have a log 3 on both sides, so what do we do to solve this? The circle. So you try to change it to exponential to solve it. So 3 to the power 3 is equal to 3d. There you go. So remember, every single time the argument is an unknown, changing it to an exponential would be the way to solve it. If you have log on both sides and they are the same type of log, it means they are both of base 6, then you can cancel them out. Now 3 to the power 3 is a 9. No, it's a 27. Remember that. 3 to the power 3 means 3 times 3 times 3 is equal to 3d. Divide both sides by 3, so d is equal to 27 divided by 3, which is a 9. Now let's try to plug it in to see if it makes sense. 9, so log 3 base 3 of 9 makes sense. So it's a positive number, so we are good. Now go ahead, try to do number 3 on your own, and we'll do this in class. Now let's move on to number 4. Okay. Now again, since we have addition, so what you can do is that you can multiply those two. So let's do that. You can rewrite it as log base 10 of x times 3x minus 5 is equal to log base 10 of 2. There you go. So you combine them. Now since you have log on both sides, you can cancel them out. So you are left with x into 3x minus 5 is equal to 2. You can do that. Now FOIL this, so you get 3x squared minus 5x is equal to 2. since this is quadratic, you need to move this to the other side to solve it. So you get 3x squared minus 5x minus 2 is equal to 0. Now, what do we do next? AC is -6, so you need to think of two numbers. When you multiply, you get -6, and when you add, you get -5. What are the two numbers? -6 and 1. So then you have -6 and 1. Remember, since a is not 1, you have to divide by a, which is, in this case, 3. So you divide both sides by 3. You simplify if you can, so you can simplify it by 3. You get -2 and 1 over 3. You put x in front of each one of them. And then you do bottoms up. Remember that? So you get x minus 2 and 3x plus 1. So from the beginning, like you can tell then from the beginning you can tell that the two values are 2 and -1/3. So 2 and -1/3 are the roots. So you don't have to do bottoms up. You can directly tell the roots from the beginning, or you can tell the roots from here. So x can be 2 and x can be equal to -1/3. What you can do is you can set it equal to 0 and solve for x. So x equals -1 over 3. These are the two values. Or you can directly know from the beginning. Remember that once you find what the two numbers are, you can directly know that the roots are the opposite. So no matter what you do, you're going to get the same answer. So 2 and -1/3 are the two answers. Now remember, you have to check if it makes sense. Now, 2, having 2 here makes sense because you can have a positive in the log. 3 times 2 is a 6, minus 5 is a 1, so it looks good. It's giving me positive answers. Now let's try -1/3. Log of -1/3, remember, you can never have a negative or a 0 inside a log. So then this is not acceptable, and we call it extraneous solution. So the only value is 2. So remember always that your value has to be a positive number if you plug it in. Like you always have to check if it works when you plug it in. If it gives you a negative inside the log, and that is not acceptable. So that is the first property. We just solved it together. Now let's move on to the other one. It's called the quotient property of logarithm. Basically, if you are dividing, you can just separate them by subtracting. Now let's move on. Now 1, 2, 3, and 4, we're going to be working those. Now again, they are divided according to rules, but you have to be able to do those without telling you, like, it's divided by rules, but you will have a practice sheet having all of those together. So every time you have a minus, it means that you divide those two. So keep the same type of log, so log base 5. Let me make this bigger so I can have more room to write. So y and 8, I basically divide them. So y divided by 8. Okay, so I combine the first two. Since I have log 5 on both, you can cancel that. So y over 8 is equal to 1, which is 1 over 1. Cross multiply. Remember, this is what's left. Y over 8 and 1. The log 5 cancel out. But 1 means 1 over 1. So if you cross multiply, you will get y is equal, or 1y is equal to 1 times 8, which is 8, and that is the value. Now let's see if it makes sense. Log of 8 makes sense. We can have a positive number. Now I'm going to let you do number 2 on your own. This is the same thing. I'm going to do number 3 with you and 4. Or maybe one of them. Let me see. Which one do you want me to do? I'm going to do 4. It's a little bit different. So I'm going to do, or I'm going to do 3 and 4. Okay. So we can combine those two to create one, since there's a minus. So we keep the same type of log and we divide them. So 3u plus 14 divided by 5 equals to log base 9 of 2u. Now since they have the same log, you cancel it out. You are left with 3u plus 14 over 5 is equal to 2u, which is over 1. Now cross multiply and let's see what happens. So 3u plus 14 is equal to 5 times 2u, which is 10u. Now you try to solve for u, so subtract 3u from both sides. You get that 14 is equal to 7u. divide by 7, so u is equal to 2. If you plug it in, you'll see that it will give you a positive number, so it is acceptable. Now let's move on to number 4. Again, subtraction, so you need to combine those by dividing them. So x plus 3 over 2x minus 1 is equal to 2. So you divide those two values. But look, there is no log on the other side. So remember, the circle thing, you change it to exponential. So it means 5 to the power 2 is equal to x plus 3 over 2x minus 1. So this is the only thing you need to check. If there's a log on the other side, like in number 3, you just cancel out the log and the log will be gone. If there's only log on one side of your equation, you can use the circle thing to change it to exponential. Now 5 to the power 2 would be 25 equals to x plus 3 over 2x minus 1. You can put this over 1, cross multiply, go ahead, try it, and you will get that x is equal to 5 over 3. Please go ahead and try it. Now let's move on to the last example, or the last rule that we learned, which is the power rule. Now, the power rule tells you that if you have a power, what you can do is you can move it down. So this works both ways. Or if you have a number next to the log, you can move it up as a power, depending what you want to solve. Now, if you look at number 1, both of them are log 10, but here I have a 3 in front of the log 10. For me to be able to cancel this out, there should be no number. So let me move it back as a power. So you get log base 10 of 27 is equal to log base 10 of x to the power 3. Now you can cancel the log 10. So you get 27 is equal to x to the power 3. Now can you think of a number when you multiply it by itself 3 times you get 27? Yes? If you can't think of it, you can just cube root both sides. So you get that x is equal to 3. So for you to be able to cancel the log, there should be no number in front of the log. So I'm going to try number 2 again. So the power would go back. So it would be log base 7 of 4 to the power 3 equals to log base 7 of b to the power 2. Now you can cancel the log. So 4 to the power 3 would be 64 equals to b to the power 2. Think of a number when you multiply by itself twice, you get 64, and that's an 8. If you can't figure it out, what you can do is that you can square root both sides, and you get 8. Now let's do one more example. So which one do you want me to do? Let me do number 3, and you try number 4 on your own. Okay, so log of 7, base 7 of 9, so this is a power, take it up. It's going to be log of a to the power 2/3. Okay, now remember, even though it's a fraction, it still goes up to the power. So log 7 cancels out, so n is equal to 8 to the power 2/3. Now my academic, you can do this on the calculator, and you will find that 8 to the power 2/3 would be a 4, so n is equal to 4. So even though it's a fraction, it still goes up as a power. My pre-AP, change this to 8. You can change it to 2 to the power 3. You keep the power. Now those cancel out. You will be left with 2 to the power 2, which is 4. Now remember, my pre-AP, you're supposed to be solving those without a calculator. My academic, you can directly put this in the calculator and you will get a 4. So n is equal to 4. Now in number 4 you do the same thing. Even though it's a fraction, it goes up. Now regular, you do it on the calculator. Pre-AP, you solve it like we learned. 4 can be written as 2 to the power 2. And that's the lesson. I hope it helped you. We'll have more practice tomorrow in class.